occurring on time and nominally just previous to this. Confirmation the burn has begun, and we have 4 good OMAC thrusters firing.
And we've got cutoff.
Starliner, good burn, and go to configure for space to space and try a comm check with ISS on the big loop.
Station Houston on the big loop. Since big loop is now set up on 2, we're going to move station calls over to 3.
Station copies.
As you just heard, some conversations between all of the players in today's...
Houston copies, Talio.
Station copies the tally. We're still looking. Looks so little from here. Give us a flash, just a signal on the window. We'll try to find you. I think we're a little below you. Your solar arrays are goalposts right now for us.
Again, with those big loops configured, that means the space station, Starliner, and both flight control rooms can all speak with each other as we get into proximity operations.
Starliner station visual. You saw my signal.
We're coming up on the...
Houston, on the big loop. Hey, we just started picking up RELNAV measurements on both IR cameras. That's when it went to silhouette track at 7,000 meters. Prior to that, in long-range track, we were not getting any measurements. We don't understand why we weren't getting measurements, but it's good that we are now getting measurements. But since we have that behavior, we had the conversation here on the ground that, of course, as you know, if once we get into Eclipse here, if we go RELNAV degraded, then diverge, the spacecraft will drop down to manual, and you're going to have to take us up to 200 meters per 11.11.301. And we expect to have good comm through that time period, and we'll give you updates should we see any other behavior or bad behavior.
We have a copy all. Right now we got Vesta 1 and 2 degraded, but we're still converged.
To take a look at the rendezvous and docking profile today, we've had 2 height adjustment and plane change burns already. Those are the NHPC 1 and 2 burns occurring at 7:52 a.m. and 8:14 a.m. Central, respectively. Those were both good burns. We then came up on the NSRPC burn. This was a coelliptic and plane change burn at 8:38 a.m. Central, another good burn, before moving to the terminal phase initiation burn. This will bring Starliner inside the Approach Ellipsoid, that invisible boundary that we monitor outside the International Space Station. And we are coming up next on the inbound fly around 1.
The inbound fly around 1 maneuver will swing Starliner out in front of ISS in the direction that ISS is flying in orbit. Then the IF-2, or the inbound fly-around 2 maneuver, will slightly alter Starliner's trajectory to hit a peak altitude in front of the Node 2 forward docking port. From there, Starliner...
Big loop for tablets. We can take another receipt on the tablet that's charging, and we're also curious on the battery status of the tablet you're using for centerline camera.
At this point in the mission, Starliner is racing towards the International Space Station. The goal? Successful docking. But there's still a long way to go. On this flight test, Starliner will have to prove itself every step of the way. The rendezvous process picks up after about 14 orbits and 21 hours into flight. At that point, the spacecraft is cruising a few hundred kilometers behind and below the station. It's time to start climbing. To do that, Starliner fires its orbital maneuvering and attitude control thrusters, or OMACs, to begin the first height adjustment maneuvers. This first burn, NHPC-1, pushes Starliner slightly in front of, but still below the orbiting laboratory. Then, the next burn, NHPC-2, fires the OMACs for a few seconds. This move puts Starliner within kilometers of station, but now Starliner is back behind it. The final height adjustment, NSRPC, is another short OMAC burn that places the vehicle on a coelliptic path with the station's orbit. Now, Starliner is just outside the Approach Ellipsoid, with the Vesta cameras in the nose pointing straight at station. After terminal phase rendezvous initiation, the proximity operations begin with a series of inbound fly-around maneuvers. Now, Starliner is just hundreds of meters away from station. Because the two vehicles are closer together, Starliner will only use its smaller reaction control system, or RCS thrusters, from here until docking. The first inbound fly-around maneuver, IF-1, swings Starliner 550 meters ahead of station and raises it another 300 meters. This maneuver accelerates Starliner to about 17,500 miles per hour, nearly matching the station's velocity. Inbound fly-around 2 raises Starliner further, moving into position 300 meters directly in front of station. Now, it's time for the initial approach. At approximately 250 meters, space station crew will manually command the Starliner to stop. This is just to verify that Starliner will obey that command if they need to issue it in the final docking phases. The approach corridor initiation burn sends Starliner into the keep-out sphere, a 200-meter sphere that nothing is allowed to enter unless it plans to dock to station. Then, when Starliner is 182 meters away from station, it will automatically stop and retreat to 200 meters. Once again, this is just to prove that Starliner will execute a retreat if needed. Starliner will then continue its approach until it gets to within just 10 meters of station. Once more, it will pause and prepare the docking system for mating with the ISS until given the go-ahead for final approach. Finally, after hours of this perfectly choreographed orbital dance, Starliner will perform its final approach initiation maneuver. The vehicle will slowly close the final 10 meters until its docking system makes contact with the Boeing-built International Docking Adapter on the Harmony Module's Node 2. Then, Starliner's docking ring will retract, hooks engage, locking Starliner and station together, signifying a successful docking procedure.
Station Houston on the big loop for the ISS cruise awareness. Starliner is inside the approach ellipsoid.
Station copies.
Again,
We're still talking about turning on the lights here on ISS. We haven't turned on any yet.
I get some reflection, looks like on the aft end, something.
And we have our first views of Starliner from the International Space Station, now crossing over into an orbital daytime over the South Pacific Ocean. We are tracking docking this morning at 11:15 a.m. Central Time, the first arrival of Starliner to the International Space Station with NASA astronauts aboard.
Starliner Houston on the big loop. Just letting you know, now that we have light outside, we're going to turn off the CETA lights just in case.
Concur. Thank you.
Expected in about 2 minutes and 35 seconds. Meanwhile, this view coming from the International Space Station, looking directly at Starliner as it moves up to the docking axis.
This IF2 burn is just a small adjustment from the IF1 burn. It will help flatten out Starliner's trajectory to get it to point more towards the approach corridor on the Node 2 forward docking port of the Harmony node. Good burner. Approaching at about 0.22 meters per second.
Always learn.
Roger that.
Okay, 12, 10, 218. We had a pulled up. We're looking at step 2.
Okay, Roger. And Starliner, we see the B2A2 jet failed off. Still talking about it, still good for control.
And mission controllers here, working through hot firing the jets that have been toggled off. They're doing a one by one, going back and forth between that and having Butch hover in the corridor.
Starliner saw a good burn performance on B2A2 and S2A2. We're going to inhibit fail off and get those back into the set. That'll restore 6th off control. and we're still assessing the other two jets.
Okay, we're standing by. You're going to do the intended fail off, and we'll be standing by for cleanup procedures.
Starliner Houston on the big loop. So here's the deal right now. We are zero fault tolerance to 6th off control, so we cannot technically get into the keep out sphere. However, we would like you to go ahead and fly us in to 200 meters and station keep at 200 meters under manual. And for reference, the attitude that we're targeting is going to be roll pitch yaw 179, 173, and 4. And you're good to do that now.
Copy, coming in to 200 meters.
Again, to keep you updated on where we are at, we are troubleshooting 4 reaction control system thrusters on the service module of Starliner. At the 260-meter hold point, the crew was scheduled to conduct a manual piloting demo. They did so by station keeping while those 4 thrusters were hot-fired, meaning they're trying to regain use of them. We've received confirmation 2 of those have been recovered, and they have instructed the crew to move into the 200-meter point. Currently, the crew does not have the go from the teams to move into the keep-out sphere and continue its approach to the International Space Station. We were anticipating docking at as early as 11:15 a.m. Central Time. We will not make that timeline, but we are still in a docking window.
Once they have
Houston on the big loop, just be advised, looks like you're doing great flying there at in the hold box. We lost the first docking window. We're going to still analyzing all the data and getting a path to approach for the next docking window.
Do that.
Watching live coverage of NASA's Boeing crew flight test to the International Space Station with NASA astronauts Butch Wilmore and Sunny Williams aboard the Starliner spacecraft. We were tracking an initial docking time of 11:15 a.m. Central Time. We will not dock during this during this current docking window. The next docking opportunity opens at 12:33 p.m. Central Time. That window closes at 1:19 p.m. Central Time. The crew is currently backing away from the 200-meter radius known as the keep-out sphere at the International Space Station. They will hold at about 250 meters away. About 45 minutes ago, the teams noticed there were some reaction control system thrusters. These are on the service module of the spacecraft. 4 specifically were beginning to fail off, meaning they would need to be reactivated. The crew took manual control of the spacecraft at the 260-meter hold point and conducted some manual piloting while those 4 reaction control system thrusters were fired.
Views, and we're following along with these views from the International Space Station. Getting great views, the sun reflecting.
We'll take point, hold, and then point back at the target, please.
Take hold, and we will point back at the target.
Good read back.
And we're tracking and following along with the teams before going ahead to press in. From this view in the orbital daytime, you can see some of the RCS jets firing as crew takes manual control.
So based on the hot fire test, the T2A2 and S1A1 had satisfactory results. We didn't get a result out of B1A3. So we're going to re-enable T2A2, S1A1, and inhibit B1A3.
distance and Starliner's flight plan for docking. First milestone inside of the keep out sphere. Currently moving towards station at about 23 centimeters per second. We're going to continue our slow approach until the 10-meter point at which we have a planned hold where we will enable the NASA docking system, NDS, and then prepare for a final docking several minutes afterwards.
Starliner is directly lined up with the Node 2 forward port. That is where it will be docking today. Also docked to the Node 2 port are the SpaceX Dragon spacecraft. That's on the Zenith side. So once Starliner arrives, we will have 2 American crewed spacecraft at the International Space Station.
Station Houston on the big loop. Starliner is inside the keep out sphere. Begin monitoring per 1.106, step 1.1.
1.1, 1.106, station.
And with Starliner inside the keep out sphere, this is the second of those 2 invisible boundaries that we use to govern arriving and departing spacecraft. The first is the Approach Ellipsoid. That's when our joint operations begin between the space station and the Starliner teams. Now, the keep out sphere, we had to wait outside of this location for a go. You have to have at least 4 orbits safe before you can move into the keep out sphere. That means if you were to lose control of your thrusters, you would not move inside that boundary for 4 orbits.
Just to make sure we're on the same page, we're inside the keep out sphere, and we are in procedure 6.102, step 28 with you.
And Starliner is with you. Light fill 2's up to 45 hits.
And Barry, that is as expected. Those will reject up until 10 meters.
And just a reminder of the NASA astronauts aboard Starliner today. Commander Butch Wilmore, it is his 3rd flight to the International Space Station after having been selected as an astronaut in 2000. He flew first to the International Space Station as a pilot on Space Shuttle Atlantis in 2009 and served as a flight engineer for Expedition 41 in 2014. NASA astronaut Suni Williams is the pilot for the CFT mission, or Crew Flight Test. She was selected to be a NASA astronaut in 1998. This is also her 3rd flight to the International Space Station, the first one coming as a flight engineer for Expedition 14, and in 2012, a member of Expedition 32.
And coming up on 40 meters away.
The International Space Station, getting a beautiful view now of Starliner as it continues its approach. We are in an automated piloting mode at this time, so the crew is not having to command the spacecraft. Starliner is designed to automatically rendezvous and dock with the space station, but we have seen the crew take manual control of the spacecraft a couple of times during this flight test. One of those happened yesterday afternoon while we were in what is called far field operations. They essentially got to test maneuvering the spacecraft in case they ever did need to take manual control. And because that test went well, they did the same thing as we were at about the 260-meter hold point earlier today.
Starliner nearing the 20-meter point, currently at about 22 meters away, still progressing at 0.05 meters per second. From Starliner's view, front of station is still fairly dark, using mostly the LiDAR sensor for feature tracking on the front of the docking, No-24 docking port. Currently, you can see Starliner's NASA docking system, NDS. The docking cover has been open for a long period of flight. Currently, the docking ring on the soft capture system is retracted. It's the inner metal ring on the front of NDS with the 3 pedals sticking out from it. Once we hit the 10-meter docking hold point, Starliner will extend the soft capture system, which is a series of motor-controlled arms. Once we start moving forward after the 10-meter hold point, those arms will remain extended. Starliner will approach the International Docking Adapter. Upon contact, there are several spring-loaded latches that will attach Starliner to station. Then, several minutes later, the arms on that soft capture system will retract. From there are several hooks that will securely latch Starliner onto that docking port, and then from there we will have hard capture.
And meter hold confirmed.
Houston copies, and Starliner, we're expecting 6-minute lighting hold before NDS configures for docking.
Okay.
Station Houston on the big loop. Starliner's at the 10-meter hold point. ISS crew perform 1.106, step 1.2.
Station copies on the big loop. Executing 1.2 of 1.106. ISS crew ready for final approach.
Houston copies.
Starliner Houston, got your fill-ins for your step 31. The maneuver to target align will be at 17:27:40. Expect final approach at 17:30. We're going to have 47 minutes of margin.
With this close-up view, you can actually get a pretty good view of what the Vesta cameras look like and where they are. Those are the two black rectangular shapes in the upper right and bottom left of that front docking port area. There's also an additional camera offset to the left, just above the orange data connection. Those cameras are spread out in different locations to help better track different features on the front of the International Docking Adapter.
Starliner Houston on a big loop. NDS and entry cover are configured for docking.
Starliner copies. We're ready.
Starliner Houston on the big loop. You are go to command final approach with tap stop 4 OFM. Trigger next.
We're on the same, putting in the trigger next. Tap stop 4.
Station Houston on the big loop. For ISS crew, perform 1.106 steps 1.3 and 1.4.
Station copies. Executing 1.3, 1.4, 1.106.
And the Starliner crew have gotten the authority to proceed for the final approach. Starliner is currently at just over 9 meters away, approaching at about 0.05 meters per second, or 5 centimeters per second, towards the Node 2 forward docking port. And Starliner passing through 4 meters.
Now less than 3 meters away from the International Space Station. Good performance calls coming from teams in mission control.
Starliner at 1.5 meters away, currently about 25 seconds from docking. .5 meters.
Contact capture.
We see the same.
At 12:34 p.m. Central Time, above the southern Indian Ocean, we have confirmation of contact and capture of NASA's Boeing Crew Flight Test and Starliner aboard the